So, dear ladies and gentlemen, let me introduce our first speaker, the representative of the company that is a title sponsor for AI Journey, Mr. Mikhail Tsvetkov, the CTO for Intel Russia. Please welcome.
Всем привет.
Hi everyone, I'm very happy to open this day with my presentation on this stage of the amphitheater. I'm glad to launch the set of technical sessions that will be pronounced today, and they will be truly inspiring. Let me start this day with a story about what matters most, about how you put the life into the neural network that you have taught. How do you make an inference, the mass inference, the mass product inference? So we are on the verge of exascale era. It's not that computational resources are becoming ever bigger. The billions and billions of operations are happening every second. But also, those codes that are used to operate those computers are changing. We're moving from HPC simulation computation with low volume of data, but with big mathematical formulas, or from ordinary data analytics, where we're getting results almost right away. We're moving to the new model of execution from the trained neural networks, when we need colossal volumes of data and computational capabilities, but we do not get the final answer from the network, but the model, the quintessential essence of knowledge, which we will have to execute and re-execute many times to get answer to each following question that we ask to the model. Therefore, we're moving to the situation when AI is actually setting a new bar for demand to the infrastructure, to computational resources, to data storage systems, and those who actually operate those computations. So, we can say that AI solves the essential tasks of this day. What is exascale? What is a billion of billion? For computations, that is a lot, but in terms of a biologist, that is less than 1 mole of some sort of substance. Why AI is booming today? Why AI is going towards new issues of life, biology, and molecular chemistry? Because those questions are the major questions that the humanity is facing these days. So, going back to the subject, execution of the trained model. We should say that AI, again, sets new benchmarks of development. The developers need to be like triathlon athletes. They need to be able to move smoothly in different environments and move in different ways while collecting high-quality data, training the model, and then deploying it. Deploy, deploy, and redeploy. So, training the model according to the projects that we see actually takes not that much time and not that much resources, about 15% of overall effort. So, preparation of data, and after that, the deployment of the model, that's the hardest part. That's challenging. And that creates a number of difficulties that we need to overcome in our infrastructures. Therefore, today, we shall be speaking mostly about inference and deployment of the trained model within data centers. For test tasks, for small experiments and pilots, we can launch most of the topologies on your laptop. 11th generation of Intel Core Tiger Lake is good enough. Or you can use desktop with Intel Core 12th generation Alder Lake. Those CPUs have important extensions like Intel DL Boost, and together with integrated graphics chips, you can quickly launch and test your models. However,
If you want the model to work, you need to integrate it into the broader infrastructure, for example, your website, so that every click, every action of the users would lead to the new instance recorded into the model, and then utilization of that result for the model. Contemporary computer architecture is based on microservices. It's disaggregated, and it's elastic, and it's meant to help us very quickly extend the capabilities of the model depending on the demand for a particular service. That is fair for both social networks and e-commerce, major banking systems, swarms. I mean, all of these types of systems are sustained by correctly selected architecture. Speaking about what sort of hardware it's better to use to launch neural networks, well, let me answer in an unconventional way. As you may see, the networks are mostly launched on microservices. So the question is, which hardware best supports microservices? By 2023, we see the growth, the forecasted growth by the factor of 11 of use of microservices in the typical infrastructure. So the product that starts in the end of 2021 will be launched on microservice architecture, while microservices are not yet optimal and as efficient as they should be. At the central graph, you may observe the yellow bars. This is the cycles of CPUs that are actually not processing the algorithm. Certain bars here are showing the inferences, and that's number 5, 3, 2, and you may see that inferences, actually, of execution of the model are only about 50, roughly 50%, plus minus, out of all the cycles of CPU. So the remaining 50% of cycles of the CPU are just servicing the microservice tasks, like offload, like network and storage operations. So, if we follow the principle of optimization, we need to look at the essence of the problem. Where and what would we need to change so that the processing resources and time would be dedicated onto the inference? So the new Intel Xeon generation, if we look at them in the abstract test environment, they show very good figures for the inference of trained neural networks, for throughput, for low latency, for stability of that level of latency. We get very, very low jitter. So that's why inference is very popular when we launch it on a CPU. You don't need any GPU for that or any other accelerators, because even if we create some sort of abstract accelerator with the inferences that could do anything in a 0 second, still we will never get rid of the overhead for the infrastructure. And that overhead must be taken into account when we're planning inferences in the system. As I have said, infrastructure based on microservices is very convenient. It allows us to quickly deploy. It allows us to use well-known APIs, SLA, sustain our SLA. That's why there are no secrets. It's no secret that microservices is the foundation of foundations. However, microservices need acceleration of the auxiliary functions. Without those auxiliary functions, microservices would not be able to work. We need infrastructure offload of the networking for the specialized devices. For example, Intel Infrastructure Processing Unit, and we build it. And after all of the operations that were made in the framework of optimization for microservice architecture, we got, as a matter of fact, the following thing that we need to solve while inferencing decent, serious product models. We need to answer the question, what is the secure way to do the project? What is the secure way to process data, client's data?
and keep them within the secure range of the model. So this is the issue of privacy of computations. It's no secret that most of the service architectures, microservice architectures, they work in the cloud. Cloud, as Mark Rusinovich once said, it's a computer that is controlled by other people, not your people. And good practice today is to always keep all of your private data in the encrypted way. When you send them via the network, when they store them, and now, thanks to Intel Tech, we can now execute them also in the encrypted protected enclave. Therefore, we are moving to the situation when you can make inferences on the microservice architecture while doing all of that in a specialized space of the CPU, the so-called secure enclave, which is inaccessible not by the hypervisor, not by the operating system. It's not even accessible to those people who have physical contact to the server. It doesn't matter where your server actually sits geographically. If inferences or processing, any other processing of data, is made in the secure enclave of the CPU, the enclave would not allow to get access to the enclave to anybody but the owner of the enclave. But for the owner of the enclave. So it's a fully hardware-software integration, end-to-end system, which is working with the microservices, giving you the new level of protection and security for AI-based systems. Now, a few words about our hardware. In order to make inferences lightning fast, so that the most number of inferences would be working together on a single node, on a single host, we are actively developing the so-called designed for AI range of solutions. This is the range of functions within conventional server Xeon processors. Next generation of Intel Xeon Scalable with the general mark of Sapphire Rapids will contain specialized matrix-based AI accelerators, in addition to the functions that will be accelerating the work of microservices. Sapphire Rapids is, in a sense, revolutionary step for Intel. It's a revolutionary step for data centers, platforms overall. This solution has been developed particularly for microservices, taking into account current demands of modern typologies of neural networks. This is a solution that is made for loading AI. And it allows to get very low latency, very low jitter while executing models that are highly sensitive to real-time operations. For example, models for processing of speech or models for real-time recommendations. New generation of Intel Xeon moves from monolith crystal, monolithic die, like we had on the Xeons of the last 12 years or something. So, starting with Ice Lake as Xeon of the third generation, now we're moving to multi-tile design for increased scalability. That's why it's called Sapphire Rapids. Thanks to this multi-tile design, Sapphire Rapids will have more flexibility and more computational resources and the aforementioned accelerators for microservices for the sake of future workloads. So, here's the growth of productivity, generation after generation. So the first gray bar is Cascade Lake, next generation to Intel Xeon, that is very widely used these days in the current data centers. So second bar is Ice Lake, third gen of Xeon that is now accessible, and you can totally use it.
Lots of our vendors offer it. And bar number 3, dark blue, is Sapphire Rapids. Up to 70% performance increase while launching unadapted microservices. Runtime acceleration for programming languages. Obviously, we're talking like super popular language like Python and Java. Let's also mention the decrease of overheads for infrastructure, thanks to integrated data stream accelerator and better management of synchronization between streams. When a number of parallel instances are competing between one another, and the much more complicated case when they compete and interact. So we facilitate that situation thanks to new distributed communication and synchronization within CPU. That's why we get almost 70% of performance increase. But the funniest part begins, the most exciting part begins when we get to AI optimization for inferences. Sapphire Rapids has the fundamentally new block, AMX, Advanced Matrix Extension. So, metaphorically speaking, we can say that the part of a GPU functionality is now becoming a part of the CPU core. So, this newly introduced AMX instructions boost the productivity for AI int 8 and bfloat 16 by the factor of 16. Bfloat 16, by the way, takes into account the specifics of neural networks. That is a new format of representation of the figure, of the value. That is very optimal for neural networks. And for int 8 and bfloat 16 compared to current family of Intel Xeon, we see the productivity boost from 64 operations to 1,024 operations per tick with a bfloat. The same proportion is for 8-bit data. There were 256 operations per tick, and now it's 2,048. That's not dozens of percent growths. That is growth by the factors of dozens compared to the previous generation of Intel Xeon. This extension is well integrated at the level of extension of the range of commands, and the software can be using these new commands directly or using one API libraries that are hiding all of the unnecessary complications from developers, providing the bottom-up, unified, unchangeable interface, unchanged interface. So how does it work technically? In the core, we have two new elements, which is a huge registry file, 1 kilobyte each. So instead of 8, it's made out of 8 2D register tables, which show us the matrix representation of data, and we have TMUL, the matrix multiplication instructions. So with one command, it is possible to execute the large matrix operation. So naturally, this is tensor processing unit with a size of 1,024 elements for one tick, without loading the ordinary processing pipeline, CPU pipeline. So the processor can be doing its thing in the meantime. So when we use AMX, take a look. These are new instructions that provide quite granular level of management of what is happening up to the level of OS core. Inside of TMUL registries, these styles, allow the optimized software to display results for productivity which are comparable to current GPU-based solutions. Take a look. If we put together
all of the performance improvements that have happened and are happening for 2021 for server platforms, Intel server platforms, in the end, we're getting practically growth by the factor of 30. If we compare it to TensorFlow as is now, if we take TensorFlow from one API optimized with Intel 1 DNN library, together with Intel Neural Compressor that has just been announced at Intel Innovation, and launch the neural network that we get with the next generation of Intel Xeon, we get the growth by the factor of 30, acceleration by the factor of 30. What more can you desire? And that includes the support of all of the current microservice architecture. And you can execute those models in safe enclave. By the way, SberCloud mentioned today that the service for confidential computations will be accessible in a framework of ML space in SberCloud. I truly recommend you to take a look at it and focus on that technology. It's pretty exciting for SberCloud. So, I would like to invite all of you today to join our software track. My colleagues will be talking about the application of all of this hardware potential with the help of Intel 1 API, which is the set of tools and libraries for optimization and heterogeneous computations. When your code, which has been written once for one platform, later can be redeployed on platforms of completely different architecture, such as discrete GPU-based accelerators, or even RPGA. All of that is accessible via one API interface that the guys will be talking at 1:40 Moscow time today at our Intel software track. Thank you! Thank you so much, Mikhail. Very inspiring presentation. Please welcome Mikhail Tsvetkov. Yes, we mentioned that we have questions, and you might have guessed we are going to ask them. Let me read them. Dear friends, let me remind you that you can ask questions to our speakers thanks to a specialized platform. This is how we get a QR code on screen. Please use your smartphone to scan it, go into the platform, and ask your questions. Just as a few people did. So, Mikhail, question number one. We don't have much time, but yet. What sort of frameworks normally work on Intel CPUs? Well, I'd be bold enough to say that most of the well-known frameworks are working on Intel CPUs hassle-free. However, we optimize the most popular ones, like TensorFlow, PyTorch. For inferences, we provide our very own toolkit, proprietary Intel toolkit, but it's OpenVINO. But fundamentally, you can launch any framework on an Intel CPU because x86 architecture is highly universal, and it's in the basis of practically any project in development at the moment. But please try to stay close to the most popular framework and download the optimized distributives for TensorFlow and PyTorch. And again, we'll be talking about that in a bit more detail. My colleagues will be telling about that. And you will get a huge acceleration compared to stock framework or stock build. Thank you. Another question. By the way, this question has 3 likes. Can we use SGX in containers? Well, Intel published a Kubernetes device driver for SGX as open source. You can find it at our Open Technology Center portal, 01.org. If something is on fire, go to that website and you'll find it. You'll find the solution to integrate into your project. Or you can take a ready-made solution, commercial solution that offer
containerization of secure enclaves, confidential compute, as they say, confidential compute containers. So you will really cut the distance to the use of commercial products for SGX in a container. Thank you. One more question. Will the new CPUs be compatible with current lineup? Oh, yes, about that. Hope in the eyes, yeah. So the biggest advantage of x86 Intel architecture is that every new generation of CPUs is compatible with the previous one. This is a huge and complex thing to do. Sustain compatibility so that the code which has been written in, say, 2008 would hassle-free run on a platform which we release in 2021. We have been doing it successfully, we are and we will be doing it successfully. However, if the code has been written for previous gen and runs hassle-free, that means that the use of the new functional capabilities needs either updating of software or transition of that software right away into the one API libraries, which are supported by Intel, by the way, and that libraries hook up these new technological solutions, again, so that it's happening under the hood, so that the user doesn't even notice that. Thank you, Mikhail, and I'd like to thank our audience for the questions. So overall, thank you very much for giving such a great overview and a great launch for our working day. Thank you for the invitation.